I don't know how long it'll take. It took a long time last time, and I might do it a little faster this time. But this is where I highly recommend in the extras, I've added these 3 commands where you do machine learning. You should all do some machine learning and learn how it goes. This is a lot of extra credit. It'll apply to any of my classes. Now, you can't get the points twice, but you can get the points in any of my classes. And I highly recommend doing this so you're literate about how artificial intelligence works. You should really have the experience of programming artificial intelligence so you can understand how it works. So let me open this up in a browser that I want to use for this purpose, which is here. I've also put the projects here on my home page. I put them in the projects for this class also. They're the same thing. So, and there's a video you can watch showing it all. In fact, I don't think there's any reason to record this. Well, you just record this one. It doesn't hurt anything. All right, so we're going to use Google Colab. Google Colab is a free online service where Google gives you access to run Python on their servers, very powerful machines, including GPUs. And so you can make a new notebook. And now you can put code here and run it. And it'll run on Google servers for free, which is bloody awesome. So you're going to use this thing called TensorFlow. You just import it and you'll see a version number, so it's working. And now we're going to do this machine learning task to start off with. Here's some numbers, -1, 0, 1, 2, 3, 4. That's X, and here's Y. -3, -1, 1, 3, 5, 7, going for these. One thing you can see is if X goes up by 1, Y goes up by 2. So Y equals 2X, and yet 0 is -1, so the linear relation here is 2x minus 1. And the reason I talk about this is the logic you just did there, that's what machine learning is going to do. You give it some data, and it just finds the pattern. It deduces this is called a model. It makes some kind of model to predict that number from this number by just figuring it out somehow. You do not write a program where you do this step, you write loops, you write if statements, you just learn. And this is why you give it a problem like winning at chess, and it would just play games and learn its own way how to get to victory without you giving it instructions how to do it. It's going to learn like a human does when confronted with the task. And this is the program that does it. And the awesome thing about TensorFlow is it is very, very simple. As you can see, it's only about 10 lines of code to do machine learning. So this is going to import TensorFlow. Here's the arrays with those numbers. And here's the model. The model is going to use one neuron, a densely connected, which doesn't really make dense, what you call it, a sequential dense with one unit. This is one neuron, so it's going to take the input, which is one number, X, and it's going to do one calculation to get to Y. And so it's going to fit the model down here, doing 500 epochs. What it's going to do is it's going to guess randomly, and then it's going to use gradient descent. SGD is a gradient descent algorithm. It will try varying the parameters to make the error smaller, and it'll go through 500 cycles of that, and it'll measure the error by mean squared error. So it will calculate the predicted Y for every value of X and find out how much it's wrong, square those and add them up, and make that as small as possible. That's what it's doing. And so there it is running. And the output will come down here. And normally it's faster than this. Hopefully it will get going. Initializing, connected. Okay, I think the first one it had to do some kind of preparation. It's executing. Okay, here we go. Here's the epochs going by. Notice this loss number. The loss number is how, first it was losing, had 5 loss, and then it improved with gradient descent, making it lower and lower and lower. So less and less, and now it's down to 0.01. And by the time you get down to the 500th cycle of learning, it gets down to 10 to the minus 5, which is almost no loss at all. And so the final number is the prediction for the value of 10. Now, with this formula, the right answer is 19 for 10, 2 times 10 minus 1. So it should be 19, and it got 18.98, so it's very good. It got quite close. It took 500 cycles of learning, and it learned how to solve that problem. So there's just more things to solve here. This is what it is. If you look at a diagram of it, X comes in, it's going to use one neuron to calculate it and get Y equals mx plus c. It's going to fit two parameters, m and c. The right answer is 2 and minus 1. And you can see how close it got by running this. You don't even have to repeat it all. We can just print the last line here, because when I wrote this, I didn't know that this is remembering everything, but it is. So if you go here, oops, I did the wrong thing somehow. All right, there. I've just put in that. It will print the values it found. And, I'm sorry, I do have to do it again because I put it in a variable called L0 here. And so I have to queue it again in order to get the L0. But I think now that I've done it once and it's initialized, it'll run faster. Let's see. So we clear the old stuff, put in the new stuff, run it. Now I save the model in L0 so I can print out the values. So here's the learning process going on. It's up to 300. It's only going to go up to 500. So, well, there we are. And when we're done, here's what it had: 1.998 and minus 0.99. So this should have been 2, and this should have been minus 1. And as you can see, it got very close, within 1% of the right value. So it's a very simple puzzle. Machine learning ought to be able to learn that. So I gave you one where you just add some errors, so it will not be a perfect fit, and then you can find a flag. And then I made one which is a parabola, a curve, instead of just a straight line. And if you try that, it's going to have a pretty miserable fit. And then, this one's fun. I managed to find an online tutorial where you can actually plot the grid. You can see the data and the findings. It's a little bit longer, but still not too hard. So this has got a complex curve which is x times cosine of x. So it's got curves and it goes up and down. And so it's going to use the data is x times cosine of x, and it's going to add some random noise, 0.1 to it, so and make 1,000 points and then fit them. And it's going to use a more complicated model. Instead of just one neuron, it's going to have one neuron to take the input data, then a hidden layer of 64 neurons processing, and another hidden layer of 64 neurons processing, and then one neuron to bring y out. So there's 128 neurons in the middle calculating it, so it's going to have a lot of parameters, and we'll see that. So it should be, there it is, training. And it's going pretty fast because this is nice, powerful hardware that Google is giving us for free. And there's the answer. So the blue dots are the 1,000 data points, and the red line is the machine learning prediction. And as you can see, it's very good. It very nicely goes right through the points. So that's cool. And now you can play with it. You can change the number of neurons in layers. You can change the amount of noise. You can change the amount of points. And there's various flags to find there. So it's very good to play with these and see how it works. All right. And then there's a couple more of these. 101, you do computer vision. Here, you use this list of clothing items, shirts and shoes and pants, and it's a fashion database available just for machine learning. It's going to sort those things into 10 categories: t-shirts, trousers, pullover, dress, and so on. That's the machine learning task, is to sort these pictures into those models. So it's going to take the pixels from the pictures and feed them into neurons, and then as input neurons, then it's going to have a hidden layer that does the calculation and then output it into 10 categories of how likely it is to be each of those 10 labels. So here's the diagram more specific. You have an input image. It goes to a bunch of pixels. It goes to the layer of hidden neurons, and that goes out to these neurons are going to tell you how likely it is to be each of those things. So you can train it here. I don't think I'll do it live. Now you see how it looks. When you train it, it'll measure the accuracy, and that's 89% accurate. And in this model, it then tested it. So first it did training, and then it has test images. It took some of the images and set them aside to test it. So you train it on like 3/4 of the data, and then you test it on the remaining data. So you see the training data, it got up to 89%, and the test data, it was up to 87%, which you would expect because, you know, it's optimizing on the training data, and it probably won't be quite as good at the test data. So then you can view the results for 20 images. You can find ones that it got wrong. Like here, the result was category 9, and these are the category probabilities, 0, 1, 2, 3 in the columns. So here it has a 96% chance of being number 9, and so they got that one right. But here's one it got wrong. It should have been category 7, but 0, 1, 2, 3, 4, 5, it concluded a 72% chance of category 5 and only a 27% chance of category 7, so it got this one wrong. So it might be interesting to look at it and see why. The first one it got right, this one it got wrong. So here's the code that will just plot out those two images, image number 0 and image number 11. And when you look at them, this one is clearly an ankle boot, and this one is funny looking. It could be an ankle boot, could be a sandal, you can see, could be sneakers with stripes. You can see why it got confused. So, just as you'd expect, then you can try training it longer to see how well it works. You can try getting a summary of the model. That learning with error titles is wrong. You see that one. And then there's another one where you break a CAPTCHA. I was very pleased to see this. So you download the CAPTCHA images from my server. I got them from some tutorial and I simplified it. Then you turn them into gray images with this process. You print out a couple of them so you see what they look like. They're just letters that are sort of twisted, tilted over. So here's a couple R's that are a little bit different. It has, I think, 10 or 20 copies of each letter, distorted in various ways, and it's going to learn to recognize these letters. So then you prepare the images with this code, which will just shrink them down to a 20 by 20 black and white image, just to make it simple. And then you create a model and train, and as you see, it's not too much code. This is going to make a sequential model with input data 20 by 20, and then a couple of pooling layers, which I'm not quite sure what they do. There's a link to the original tutorial that might explain it a little better. And then there's the dense layer. This is 500 layers of calculation that does it, and here's the output layer. So just like the last one with fashion, we prepare the data, we have one layer with 500 nodes, and then we have 32 outputs because there's 32 possible letters and numbers in this data set. And so when you run that one, it will train for 7 learning cycles and get up to 92% accuracy on the training data. And and the second number is the test data. It's only 86% accurate on that, which is what you'd expect. And you can get a summary. You can find a flag there to show you know how to do it. So one thing to learn from this, which I'm hoping you're getting, is if you think about ChatGPT that takes an input question and just prints the answer, if you wanted to give it a rule, like do not publish any politically forbidden statements, like in China, you cannot say anything bad about the Communist Party, or in America, you cannot tell anybody how to commit a bomb or help somebody with suicide or anything like that. There's no easy way to put that kind of restriction in here. There's no if-then statements or numbers. It's not clear how you would control this thing. It just learns from the learning data, and it repeats that back when you have future questions. So this is the problem. That stuff is getting more powerful incredibly fast. The power is increasing by a factor of 10 every year, and it's going to be everywhere. By next year, we're all going to be using AI everywhere for everything we do, and yet we've developed it so fast, we don't really have any real idea how to control it yet. And that's why people get upset, like Elon Musk writing this letter saying we really should pause for 6 months while we define rules of what would be acceptable morally and how to enforce them before we develop it anymore. But that is totally not happening. Everybody's developing it at top speed in every nation and every company. It's going to be here, and we really don't have much of an idea how to control it yet. So that's why I really want you to all do it and get on board and be prepared for the brave new world. By next year, everyone's going to expect you to understand this and know how to use it everywhere. Anyway, that's it. I'll stop this